In this video, I'm going to show you how to compute the angle between two vectors, a and b. The solution is just to use the dot product. One of the formulas for the dot product is that a dot b is the magnitude of a times the magnitude of b times cosine of the angle between them, theta. So we can solve for theta by first dividing by the magnitudes. So we get a dot b divided by magnitude of a times magnitude of b. That's equal to cos theta. And then we can apply the arc cosine to solve for theta alone. So this here is our big formula that we're going to be using to find the angle between two vectors in the upcoming examples. Let's try out that formula on a concrete problem here. So we want to compute the angle between a vector a, 1, negative 2, 3, and another vector b, negative 1, 0, 2. And we're just going to substitute these vectors into our formula here and compute. So theta is the arc cosine of a dot b. So let's write that out. A dot b is 1 times negative 1. And then we've got minus 2 times 0. And then plus 3 times 2. And we'll put that as a numerator in the fraction. And then the denominator, we've got the magnitude of a, so the square root of the sum of squares of its components, so 1 squared, and then plus negative 2 squared, plus 3 squared. And then for b, that's also the square root of the sum of squares of its components, so negative 1 squared again, plus 0 squared, plus 2 squared. Okay, so now we just need to go ahead and do these computations. So theta equals arc cosine. Let's do the numerator first. This is 1 times negative 1, that's just negative 1, and then minus 0, and then plus 6. And now in the denominator, I've got the square root of, this is just 1, and then negative 2 squared is 4, so 1 plus 4, and then 3 squared is 9, so plus 9. And then the other square root comes out to negative 1 squared is 1, then 0 squared is 0, then 2 squared is 4. And then we'll go ahead and keep simplifying. That's the arc cosine of negative 1 minus 0, still negative 1, plus 6, so 5, over square root of 1 plus 4 is 5, plus 9 is 14, times the square root of 1 plus 4, well that's just 5. So theta equals arc cosine of 5 over, multiply these roots, and 14 times 5 is 70. And if you punch this in your calculator, then you're going to get out that theta equals 53.3 degrees. And there we have it. That's the angle between those two vectors. Plugging vectors into our angle formula is pretty straightforward, so here's an example that mixes it up a little bit. We want to compute the angle between a, which is a vector negative 2i plus j, and the positive x-axis. So we want this angle here. But how do we do this if we don't have another vector? We've got a, that's a vector, but then we want to compute the angle relative to the positive x-axis. Well, we can choose a vector that's parallel to the positive x-axis, and that'll give us the same angle. So why don't we do that? I think the simplest vector is probably the one that just goes 1 unit to the right. This one here. Let's call that b. And let's get the components of b. So b just goes 1 to the right, so that's I. And then it doesn't go up at all, so just 0j. So we'll just leave the j out. Okay, so now we're ready to go ahead and find the angle between these two vectors, a and b. We know how to do that using our formula. Theta is just arc cosine of a dot b over magnitude of a times magnitude of b. And we can just go ahead and plug and chug like we did in the previous example. So arc cosine a dot b, well, that's negative 2 dot 1 in the I component, so negative 2 times 1, so just negative 2. And then in the j component, we have 1 times, well, there's no j component here, so that's just 0. So 1 times 0 is just 0. Alright, and then the magnitude of a, magnitude of b. Magnitude of a is square root of the sum of squares of its components. So negative 2 squared, which is 4, plus 1 squared, which is just 1, so root 4 plus 1. And then magnitude of b is just square root of 1 squared, so square root of 1. Okay, and now we can simplify this a lot more. So theta equals arc cosine. Negative 2 plus 0 just goes to negative 2. And then on the bottom we've got root of 4 plus 1, that's root of 5, and then root of 1 is just 1, and root 5 times 1 is just root 5 again. So here we have it. That's our theta. And we want to get an actual concrete angle measure here, so let's punch this into our calculator. And we do so, and we get that theta is 153.4 degrees. So there we go. That's the angle between our vector A and the positive x-axis. Since we've got a nice diagram here, we can also check that our angle makes sense. Our angle is an obtuse angle, and in the diagram the vectors are diverging, creating an obtuse angle. So yeah, that makes sense. The angle is also closer to 180 degrees than it is to 90 degrees, and indeed 153.4 degrees is closer to 180 degrees than 90 degrees. Great, so it all makes sense. Everything looks good. Here's another example which mixes things up a bit. We're given 2 points, A and B, and we want to compute the angle between AB, the vector from A to B, and the other vector, V, which is 3, 2, negative 4. So here we've got a diagram of the situation, and we've got A, we've got B, we've got our vector AB, which runs from A to B. But how do we express the components of AB? How do we get those? Well, in order to do this, we're going to have to perform some vector arithmetic. And in order to do that, we're going to need to have some vectors to work with for A and B. So the bottom line is we should really introduce an origin here. Let's call this point our origin. And we can write down vectors that go to A and that go to B, and we can use those two vectors to compute the vector between A and B. So okay, so first of all, the vector that goes to A. Well, the origin, that's just the point 0, 0, 0, and then the vector that goes to A, we'll call that A, lowercase a, and that's just the coordinates of A as a point just written inside of a vector. So 3, 4, negative 3. If we start at 0, 0, 0 and then go along this vector A, we'll reach the point A. Okay, and then for B, it's kind of the same idea. We define a vector B, which has as its components the coordinates of B. So 5, 3, negative 2. And this vector will take us from the origin to the point B. Okay, so now that we've got two vectors, A and B, which tell us how to get to A and B, the points from the origin, how do we compute the vector AB? Well, we can go ahead and subtract. We can just take the vector B minus the vector A. And the reason we can do that, the reason why we can take the terminal vector minus the initial vector, is that we're really just going negative A to the origin. We're following the vector negative A to the origin, and then we're following the vector B, just regular B, to the point B. So we're going from A to the origin to B. So that's negative A and then plus our vector B. But you can also remember, it's probably easiest to remember if you just think the vector which goes to the terminal point, B, minus the vector which goes to the initial point, A. Okay, so we've got that our vector from A to B is given by B minus A, and let's go ahead and compute that. So B minus A, well, B is just 5, 3, negative 2, and then A is just 3, 4, negative 3. And let's compute what the difference is. So 5 minus 3, that makes 2. 3 minus 4 makes negative 1. 2 minus negative 3 is just 2 plus 3, so 1. Alright, now we've got two vectors. We've got V and we've got AB, both vectors, and we can find the angle between them by just plugging and chugging into our formula. Theta equals arc cosine of AB dot V over norm of AB times norm of B. Okay, so let's go ahead and plug this in. Theta equals arc cosine. AB is, well, AB dot V, that's just multiply the components in the atom, so 2 times 3, that's 6, and then negative 1 times 2 is negative 2, and then 1 times negative 4 is minus 4, and we're really just about done here. We don't even have to compute the magnitudes because look at this top here. 6 minus 2 minus 4, that all goes to 0. So it really doesn't matter what the magnitudes are. We know that theta is just going to be the arc cosine of 0, because 0 divided by anything is just 0. So arc cosine of 0, what angle has a cosine of 0 degrees? Well, that's just 90 degrees. So there we have it. Our angle is 90 degrees, which tells us that our vector V, let's draw it in here, it's really just perpendicular to the vector AB. The angle is 90 degrees, that's the right angle. This also gives us a nice check if we want to tell whether two vectors are perpendicular. All we have to do is take their dot product. If their dot product evaluates to 0, then the angle between them is the arc cosine of 0, which is just 90 degrees, so they're perpendicular. In the future, we'll also use the dot product to accomplish other tasks with vectors, such as projecting a vector onto another vector.